Hello, this is video number 39. This is going to be a short video. I called it the sign of the work, so I just wanted to make a video on this topic. It's not the most interesting topic, but it's really important that when you're calculating work, that you know if it's positive or negative. So I just wanted to make a whole video so that we really pay attention to the sign of the work. So how do you know if work is positive, negative, or if it's zero? So the best way I can explain it is that the work is positive when the force is in the direction of the motion. So in this case, both the force and the motion are to the right. That would be positive work. And then the work is negative when the force is in the direction opposite the motion. So you can see that this force has a component to the left, and that's what would be doing work, as we said in a previous video, that the force has to be parallel to the motion, but it's in the opposite direction. So that force would be doing negative work. In part A here, it was the x component of that diagonal force that was in the same direction as x. And then the last thing is, well, how do we know if a force does not do any work on an object? So the best way I can think of it is that there's no work done by that force if the force is perpendicular to the motion. So the force can be perpendicular up here or perpendicular down. Since the motion is to the right, that force is perpendicular, it doesn't do any work. So in my experience, whenever you do a problem, you always want to just go back and think to yourself, okay, what's the relationship between the direction of the force and that of the motion? And that will tell us if that work is positive, negative, or zero. So let's do a few questions to make sure we got the hang of this. So the first one here, a constant force pushes a particle through a displacement, and in this picture the displacement is called delta r instead of delta x. That's okay. In which of these three cases does the force do negative work? So we just said that the force had to be in the opposite direction as the displacement. So in this case, the displacement is diagonal here. Now this force would have one component of it that would be in the opposite direction as the displacement. If you resolve the force into its two perpendicular components, you can see it's opposite direction. So that's negative work here. And likewise for part B here, it's in the opposite direction. The displacement is to the right, the force is to the left. And if this first one confused you here, you can just think, okay, the displacement is to the left. It has part of it that goes to the left while the force goes to the right. So both of these forces do negative work. Part C, you might think, oh, it's negative work because that force is going to the left, but that's not how you think of it. You have to look at both the force and the motion. They're both in the same direction, so that means this work is positive. So the best answer is A and B for this one. Let's do another similar one here. A crane lowers a girder into place at constant speed. Consider the work Wg done by gravity and the work Wt done by the tension in the cable. Which is true? So you have this girder here, and the gravity is going to pull it down, and the crane is being lowered, so the displacement is down. That force of gravity is down, but the tension is going to be holding up the object as it's being lowered. So which is true about the sign of the work? Which work is positive, which work is negative? Well, the gravity is in the same direction as the displacement, so gravity is doing positive work, so we can get rid of the last three here. And the tension is the opposite direction, so the tension is doing negative work. So our answer is B. So that's the end of this video, and you might think, well, what in the world, why do we care about the sign of the work? And the answer to that question will be in the next video, video 40, that it's going to tell us about the energy of the system, whether you do positive or negative work. So let's go ahead and move on to video 40.